Okay, we're going to work with
Yes.
nice bank shot. Finding standard deviation. And if you remember right, standard deviation went along with our normal curve. Remember when we talked about a normal curve, which was shaped like a bell, and it was divided into 4 sections on each side. Each one of these is one standard deviation away from the mean. Remember doing that?
Yeah.
And over here, the same distance this way. But each one of these divisions is based on a standard deviation.
What chapter is it?
I don't think it's any chapter. It's just something that I have to cover because it's in the curriculum. Because we talked about probability and statistics and all that kind of stuff before I left. This goes along with it. Okay, standard deviation is based on the mean. And distance from the mean. So if I had, we're going to keep it real simple here, if I had a simple set of data like 0, 1, 6, 4, 3. Okay, 5 pieces of data. If you start getting more than that, it's going to take you forever to figure this out. Okay? But the first thing that I need to do with this standard piece of data like this is, first of all, I go through and I put it in order from smallest to largest. And then I find the mean. First step is find the mean. So if I do that, I have to add all of these together and divide by 5, correct? So 6 plus 4 is 10, 13, 14 divided by 5.
3.78. 3.8. Oh,
I think it's more like 2.8. Okay? Symbolized, mean is either this, an X with an arrow or a line over the top of it, which means mean, or a Greek letter called mu, which looks like that. So if you're looking in a statistics book, they may use this, but it means the mean. So if I am finding standard deviation, it is actually looks like a complicated formula, but set up a table. You're going to list all your x's. So I'd have 0, 1, 3, 4, 6. Then I'm going to take x minus the mean. So if the mean is 2.8, what's 0 minus 2.8? And what's 1 minus 2.8? And what's 3 minus 0.28? And what's 4 minus 2.8? And what's 6 minus 2.8? What'd you say?
3.2.
Okay, so I need to find the difference. Then I need another column. And it is actually the difference squared. Okay? So I need to find all of these and square them. So I need a negative 2.8 squared.
7.84.
And it turns positive, doesn't it? Because I'm taking a negative times a negative. And then I need a negative 1.8 squared.
30.5.
And a 0.2, I bet, is about 0.04. Then a 1.2 be about a 1.44. I'm getting lucky. 3.2 squared.
10.2.
10.24. Okay? We all right with that? So far it really hasn't been hard to do. It's just a matter of, if you add 100 numbers, it's going to take you a long time, isn't it? Do you agree? Okay? So now, what do I do with all of these? I find the sum. That means I take 7.84, add it to 3.24, add it to 0.44, add it to 1.44, add it to 10.24. 23. Okay, so this is called the sum. I'm going to take that 23.2 and divide it by how many items there were. So in this case there were 5, weren't there?
4.62.
4.62, did you say?
4.
Okay. And my last step is find the square root of that. 2.2. Okay. That is my standard deviation then. 2.2. Okay. Which means that if I had my normal curve from the data that I just did, what was my mean? It was 2.8, wasn't it? Right? One standard deviation to the left and the right. And you remember what these percentages were?
34.
Okay. So 34% falls to the left of the mean, 34% falls to the right of that mean, if it was a normal curve. And the standard deviation was 2.2, which means from here to here it would be 2.8 minus 2.2, which means this would go down to 0.6. Sorry, this one would be 0.6. And 2.2 added to 2.8 would be about 5. In the list of numbers, correct?
Yep.
So I add one standard deviation this way, I subtract one standard deviation going this way.
And what's the standard deviation? 2.8?
2.8 was the mean, standard deviation was 2.2, that's what we calculated it as.
So what do we have to do with the 5?
In other words, the numbers, 68% of the numbers are going to be between 0.6 and 5.
Oh, all right. Okay.
From the list of numbers that you had over here, the 0, 1, 6, 4, and 3, approximately 68% of those numbers will be now between 0.6 and 5. If I wanted to find 2 standard deviations from the mean, I would take the 5 that's here, because that's one standard deviation, isn't it? And wouldn't I have to add 2.2 to get to the next one? Which would be 7.2. And over here I'd subtract 2.2, which I believe would be about a negative 1.6. Now, this was like 13.5%, and this was 13.5%. Remember when we had those drawn out before? So 68 plus the 27% would be about 95% of my numbers would be within 2 standard deviations, right? Where would my third standard deviation fall then? So I take 7.2, add 2.2, get 9.4. Subtract 2.2, I'd have a negative 3.8. And the fourth standard deviation, I take 9.4 and add 2.2 would be 11.6. And this one would be about a negative 6. Right? Okay. If I looked at all of these numbers, would 100% of my numbers, and that's what it's saying, have to exist between negative 6 and 11.6? Do 100% of my numbers exist between there?
Yeah.
It's 34, then 13.5, then 2, and 6.
Okay? So, do you remember all those times when you were taking some of those tests and you got results back and they said you fell within 1 standard deviation of the mean, 2 standard deviations of the mean, etc.? Like some of the old achievement tests that you took? That's how they determined that. They took everybody's score and added it together, found the mean, then found the difference between your score and the mean, found the standard deviation.
2, and then 0.5.
That's why, like now, when you take an ACT test, even though it's not a normal curve, they still do the same type of thing.
And that's why almost everyone got a 21.
That's why sometimes you can actually get more answers right on an ACT test and get a lower score because you're taking it with somebody else that's getting more right than what you are.
Who do they compare that to?
Huh? Whoever's taking the test that day. Whoever takes it that day. That's why they have specific days that they take it on. Specific times. And everything. Okay? Let's do another set of data. Let's do 2, 6, 5, 3. Let's see, we got 11. 11 and 3 is 14, 15, 16, 4. Okay? So the first thing that we do is we are going to have to add these all up, right? So 2 and 6 is,
Put them in order first.
okay, 2, 3, 4, 5, 6.
Sorry.
So 6 and 4 is 10, 5 and 2 is 7, plus 3 is 10, 10 and 10 is, the sum is 20, right? Got 5 numbers, so the mean is going to be 4. Okay? That means I'm going to list them down this way. Over here we have x minus the mean.
-2.
So I'd have a negative 2.
1, 0, 1,
And 2. Right? Over here, I'm going to square it. So this would be 4, 1, 0, 1, 4. Find the sum. So 4 plus 1 is 5, plus 1 is 6, plus 4, the sum is 10. You will see this symbol used in statistics. It's called sum. It's a summation symbol.
Oh, it's the...
An E. Epsilon.
Sounds like an Excel, isn't it?
Yeah. Okay? So I found the sum, didn't I?
Divide by 5.
Okay?
How many numbers you have?
2. So I take the sum, divide it by 5,
Which is 2,
which is 2,
square root of 2,
and find the square root of 2, which means I would have a standard deviation of 1.414. Okay? That's how I find standard deviations. Now, can you imagine if you had 10,000 numbers to go through?
no, I can imagine it, I can do it.
Okay?
I give up.
Get out your Chromebook.